Hello, good day viewers. Here we're giving another interesting Olympiad math problem, and guess what? It happens to be another interesting diophantine equation. Just like I told you guys in my previous video, that a single equation with two or more unknown variables is called a diophantine equation. In this video, we are given x cubed minus y cubed is equal to 19. We're asked to find the value or values for x and y, given that they are what? Integers, right? So please subscribe to my channel. If you have not done that, subscribe just to support my channel. Thank you so much as you do that. Here we're given x cubed minus y cubed is equal to 19, right? So at the left hand side, I'm going to make use of the difference of two cube formula, right? So here I'm going to have x minus y, right, multiplied by x squared plus xy plus y squared is equal to 19, right? So let us look at these two factors. Just take a note that x squared plus xy plus y squared will always be greater than x minus y, right? Okay, so actually from the right hand side of this equation, we're going to factor 19 as follows. That is 1 times 19, right? And having it known that 19 is also greater than 1 from here. So here we have x minus y multiplied by x squared plus xy plus y squared is equal to 19. We'll write as 19 times 1, right? Recall when I said that x squared plus xy plus y squared is always greater than x minus y for real values of x and y, right? If you check it out, you see that the equation holds, right? Or the equality holds, I mean. So, and here we have to factor this 19 as follows. 19 times 1, having it known that 19 is greater than 1. So actually mean that we're going to compare as follows. This equals this and this equals 1, right? So here we have x minus y is equal to 1, and also we get x squared plus xy plus y squared is equal to 19. Okay, from this equation 2, let us call this equation 2 and this equation 1. So we're going to write it as follows. X squared plus here y squared then plus xy is equal to 19. Let us make use of this property that a squared plus b squared is equal to a minus b squared plus 2ab, right? So we have to use this very nice identity here. So this is going to give us x minus y squared then plus 2xy plus xy, and this is equal to 19. There's another identity, a squared plus b squared is equal to a plus b squared then minus 2ab. Why I did not make use of this is because I've seen that in my equation 1 I have the value for x minus y, so which actually means that the best option is to go for this, right? So we can make this substitution right from here just to get the value for x times y. But let us first simplify this. Plus here we have x minus y squared then plus 3xy. This resulted to 19, right? So from here we know x minus y is equal to 1, so here we replace 1 squared, that is 1 plus 3xy is equal to 19. So subtract 1 from both sides, so we get 3xy is equal to 18. Divide both sides by 3, we get xy is equal to 18 divided by 3, and that is what? 6. So we get here x times y is equal to 6, right? Okay, now we have to depend on these two equations. X minus y is equal to 1 and xy is equal to 6. But from here we can solve for y in terms of x, or we can solve for x in terms of y. Let us go ahead and solve for x in terms of y. So here we have x is equal to 1 plus y, right? Okay, now we're going to insert the value of x in terms of y in this equation 2 here. So here we get y open bracket x, which is 1 plus y, is equal to 6. So let us open up these brackets. We have y plus y squared is equal to 6. Here we have y squared plus y. 6 is crossing over, becomes minus 6 is equal to 0, right? So let us factorize this. Let us think about two numbers that when we multiply them we get negative 6, and when we add them we get positive 1. That is the coefficient of y. So I'm thinking about negative 3 and positive 2, because negative 3 times positive 2 is negative 6, but negative 3 plus positive 2 will give us negative 1, so which is not the two numbers. These are not the two numbers needed here. So let us say positive 3 and negative 2. Positive 3 times negative 2 is negative 6, and when we add them we get positive 1, right? So we're going to factor this as follows: y plus 3, then multiply by y minus 2, right? Then, so this is equal to 0, right? So from here we have y plus 3 is equal to 0, or y minus 2 is equal to 0. So here we get y is equal to negative 3, or y is equal to 2, right? Okay, now let us solve for x. Recall that x is equal to 1 plus y. So here we have when y is equal to negative 3, then x is equal to 1 plus y, and this is equal to 1 minus 3, and this is equal to negative 2, right? So you know this is x1 and this is y1, right? Okay, again, when y2 is equal to, here 2, then x is equal to 1 plus y, and this is equal to 1 plus 2, and this is equal to 3, and this is what? X2, right? So we have found the possible real values, the integral values for x and y in this equation, and we can put them in the following pairs. Here we have x, y, and this is equal to, the first pair will be the value for x1 and y1. So x1 is negative 2, y1 is what? Negative 3. And again we have x2, that is 3, and y2 is equal to 2, right? And these are the required values. Thank you for viewing. Please do wait to subscribe to my channel and share my video.